Just a normal day in the Cretaceous, just a normal rock flying through space. Don't look at what happens. So here we have a lovely Cretaceous forest over on this side. Don't pay any attention to what's up there. This is roughly what it would have looked like at the end of the Mesozoic. This particular picture is from around the middle of the Cretaceous. Early to middle, around 120 million years ago. And then, okay, now you can look up at the top. Oh my gosh, giant rippling waves of destruction. And this is the day. So the Mesozoic ended on a particular day. Now, the Paleozoic probably didn't. The Paleozoic ended over a period. And it may be several thousand years is that period. And because it's just an extinction, it wasn't like a particular event. It was a buildup of things to the point where stuff started dying. And when most of the stuff had died, then we'll call that the end of the Paleozoic. But the Mesozoic is very much an era ended in a moment. So the impact crater from this object, and it may be that it's a meteorite, it may be that it's a large comet, although leaning more toward something like a meteorite. Or rather a meteor as it's coming down. This thing impacted in the Yucatan Peninsula, and we have lots of evidence for this. So part of the evidence is, so we think right after there would have been these little ridges of mountains, and those have been worn down in the roughly 66 million years since the bad thing happened. But what you do get is a ring of cenotes. And cenotes are these little underground cave-like structures. And darn if they don't follow the sort of edge of the impact crater really nicely. And you can see them spread all over the place over here. It's where the limestone underground has been eaten away, I think, for the most part. And suspiciously, almost none appeared in the 65 million years since in the area where the impact crater actually was. So the actual impact may have been just offshore. Imagine a circle, and the center of that circle be right about there. So there you go. All right. So what we're talking about in this particular one is what happened on that day 66 million years ago. And this is a bit of very flowery prose. It's kind of neat. And the upshot is that, this is in a day. So what happens is you get an impact. The impact is going to be notable today because you can see these structures. They're called impact breccias. And it's a compacted form of rock that forms under high pressure and high heat that you get around impact craters, and that's really the only time that you get this sort of deformation of rocks. So it's going to be a type of metamorphic rock, something that was maybe sedimentary originally, and then after the impact has been converted into this special impact rock. This, we think, lands on the ground or in the ocean, but over the sort of shallow ocean. And so one thing this would cause is gigantic waves. That's what we would expect. Now we're going to compare our expectations against the fossil evidence. Another thing we would expect is that a lot of whatever it is that hit the ground, because we haven't found any traces like solid chunks of this thing, it would have been essentially vaporized or liquidized and then vaporized, something like that. And so it would have also vaporized quite a bit of the underlying substrate. Now, the crust of the Earth is mostly silica. Aluminum and silica are dominant atoms that you would find on the surface of the Earth. And so when that silica is going to be turned into essentially like a gas, it's then going to form. It's like the precipitation cycle, only with fiery glass, because it's going to be really hot. And so you get the glass condensing into little droplets, and the little droplets will then fall like rain. But it'll be rain that is 500 degrees, maybe a little hotter. And when it hits the ground, it's not going to splash. It's going to start a fire, basically. And so we think that is probably what happens. And we have evidence from sites that are around this age that there is an ash layer that you can find anywhere that you care to look on the Earth. If you are looking at the right time, there is ash. And this ash is widespread. This ash covers the areas that used to be forests. It suggests that the forests basically burned, that most of the Earth's surface was effectively on fire because of this rain of molten glass everywhere. Because once it goes up really high, the Earth is still turning underneath it. And this stuff is just going to circulate around the Earth and then rain down. There may have been several waves of this hot molten glass raining down as it sort of dropped out of the atmosphere, coalesced, and came down. And this was bad. Like it says here, about 99.999% of all things that were alive the previous day were no longer alive when the fires had died down. The carbon cycle, like using things, fixing carbon, other big fish eat the little fish, all that stuff, essentially interrupted. This was a terrible time for plants and animals and just about everything to live on Earth. But where else are you going to go? Yeah, this is the end of the Mesozoic. Here's some of the geological evidence for the end of the Mesozoic. So you've got, in calmer times, I think you get these fine little bands, and you get sort of gradual deposition as things filter down through the water and then pile up. And there may be a little storm, there may be a little extra runoff, you may get a little landslide, so you may get little extra bits of something in there. And then there will be times when you just get chunks of stuff appearing fairly far offshore, because it's the area where there used to be quite a lot of really thin layers of fine material, which is what you'd expect. And you get just, look at all this chunky stuff in here, chunky, disorganized stuff. This would be indicative, geologists would call this an event layer. Event usually meaning bad event, really bad event for living things, but like a record of a thing that happened, like a thing that involves a lot of very sudden erosion, sudden moving of sediments from one place to another. Underneath this event, and I think this is related to it and not something that appeared later, you've got these sort of ripples like that. These are wave marks. And you can go, and if you're into scuba diving or even snorkeling, you can look underneath the waves, and you can see it's like a really small miniature version of waves. But they'll pile up the sand. And the size of the piles is correlated with the size of the waves above. And so if you can estimate what the rough depth was there, which you can do from the particle size and distance from the nearest, delta, then you can estimate how big the waves would have had to have been in order to generate, wave deposits like this. Here's another surge pulse down here with great big wave deposition in there. So it's like two gigantic tsunami-style events, and I don't know why there's two. That is a mystery, or if they're probably related to each other, but I couldn't tell you. It may be, I'm just guessing. I would just be guessing if I was saying this. Anyway, these come from a site called the Tanis deposit, and these are one of the records of the end of the Mesozoic, the end of the Cretaceous period happening. And they're really a fascinating record because this is from near the shoreline. But a lot of this formation actually is up on land, areas that would have been a couple of miles potentially from the actual beach. And you find storm surge debris like this, even in places like that. It's really cool. So let's talk about it. What's this look like? So when you get a bunch of things and they die, they're usually not all facing the same direction. When you get a bunch of things and they die and they're thrown up on land by waves, now waves have a real directionality to them. They push in toward shore and then they pull back out from shore. It's very linear like that. Usually you don't get this sort of sweeping, but even if you do, it's a very constant sweep generally. If you're talking about a couple of really big waves, a tsunami, something like that, then yeah, the biggest waves are going to be the ones that throw stuff farthest up the beach, and they'll be going in a direction very definitely. And so what you get at these sites are a bunch of fish that are all dead, and they're fossils now. Yeah, so that's the happy ending. But they're all oriented. All their heads are facing this way. All their tails are facing that way, or very close to it. And you find logs thrown up here with these things, and you find chunks of other animals thrown up here. This is the result of a really strong storm surge that threw a bunch of stuff onto the land. Now, theoretically, this could be any storm surge. Real bad storm, a bunch of fish get thrown up on the beach. It happens from time to time all over the place. What makes these special is that in these deposits, where you get the fish, you get all these little dots. And the little white dots are little beads. They're little beads of glass. And you can actually cut into these beads of glass, and you can tell that at least the centers of these beads were still molten when they went into the water. So they like flash froze, or flash heated up the water, yeah, as you like. And so this is the rain of glass pellets coming down. This is the storm itself. This is like the early event. These are chunks of material coming down with just the first few beads. The beads take a little while to coalesce, and they rain a couple of times. These may be days apart. These may be a week or two apart. It's hard for me to tell. You can model these things, but it's hard to be absolutely certain. And so you have a record of some very bad stuff happening. And then the iridium anomaly. So there's a lot of... Iridium is fairly rare in the Earth, in its crust. But on some asteroids, it's a thing that is much more common. And so you get this layer of iridium. And that's right up here. And we think this may be sort of the last bits of the sort of last bits of the impact material actually settling down to Earth finally, and forming this nice little band. So as the skies are starting to clear finally, potentially. And then after that, we have now exited the Mesozoic. Okay, so this is the Hell Creek Formation. There was a river here at this time, so we're at a river inlet, and so the river was flowing. The deposit has been thrown up the river, essentially, so it's kind of following the path of the river, but everything is facing the way it would face if it was thrown up by waves coming from the ocean, basically pushing up the river. So that's neat. It's pushing up the river, ripping trees and fish and everything off, and throwing those way up onto the land. And this is your deposit area in this formation, on top of the Hell Creek Formation. This is the deposit from the Tanis event. All right, so what do we see? So we got this on top of our Tanis event. Here's our event deposition. Here's our iridium layer. And then just on top of that, we've got this giant carbonaceous shale. If I'm remembering this correctly, I think that may be actually from, we think, the giant forest fires that are burning virtually worldwide, everywhere that there are forests, from the molten glass raining down. The molten glass is raining down, we think, everywhere, even very far away, because this impact crater is down in Mexico, so it's pretty close to the equator. And the Hell Creek Formation is all the way up in, I believe, Montana. So those things didn't get any closer in the last 66 million years. And so we're talking about very distant, very severe effects from this impact. Here are some of the little drops of glass. Here's a section of the glass, and so you can see the inner part kind of cooled in one event. The outer part was sort of slowly cooling as it was falling down, but the inner part would have still been liquid and red hot when these things hit. And then once they hit the water absorbs all the heat, and they just solidify as they were. But that's why you get these different layers in there, the ones that build up slowly versus the ones that sort of flash freeze in there. And so if the center of this was that hot, then these things were probably hundreds of degrees falling down from the sky. The worst hailstorm you've ever heard of. In addition to that, you get ejecta coming down. And so even though it's like a quarter of a globe away from the impact site, you get stacks of these. Look at these little spheres piled up. That's how densely they are raining down. Yeah, all the way up in North America for this thing that happened in the southernmost part of North America, or you could call it Central America. And you also get like chunks of material, probably from the impact site, that have been thrown out, gone through the air, and are now landing and are now making a little indentation, like we would call these drop stones, if it was caused by just melting of ice and then stones falling down, like a melting glacier dropping stones. These are probably dropped, though, from the impact, from very far away. So that's crazy. Here you can see some of these other little glass spherules from the Tanis event. And they look like glass spherules that you get over a range of sites. And I guess we should point out there are some things. I'm using a lot of pictures from the De Palma paper. There have been some ethical concerns about this paper. Not that the data itself is wrong, but that there was like a larger group and somebody died, and somebody took a bunch of the data and then didn't give credit for the other people who had actually submitted the data. So it's like that kind of controversy. You can watch plenty of stuff on the internet about this. Just came out, but that's interesting, but it doesn't fundamentally change the story that we're telling here. Here's the most telling thing, and you get versions of this in this paper and in the other paper that came out like a year or two after, and has more careful analysis, particularly of the fish data. So these are the gill arches and the gills of these fish, and it's the gills that are loaded with these little, what would have been red hot little balls of glass. So that tells you that these fish, that are the ones that were thrown out, and they're probably ocean fish, but they've been thrown out of the ocean onto the shore, and they're full of this sort of impact molten glass. And you would not imagine having molten glass shoved up your nose. Yeah, you wouldn't want that, or in your lungs. That's basically what's happened to these poor fish, lungfish. Yeah. Now, from this data that tells you that a bad thing happened, and we can say from dating things above it and below it, about 66 million years ago, plus or minus. But you can actually narrow it down much more. So if you look at the lungfish, so these are on, I believe, the teeth of the lungfish. They can do sections. And in these sections, you'll see these little areas. And the areas are where the layering gets really thick or the layering gets really thin. And so you'll have these, like many other creatures, have sort of seasonal bone growth related to temperature and availability of food. Actually, no, sorry, this is on the spines. They have a bony spine that supports the pectoral fin. Sorry. And that's what these are sections of. So they're going to grow from the outside. We're going to build up new layers constantly, but we'll build them up faster when it's warmer and when there are when we're eating more, when we have a higher metabolism, because it's going to be related to that. And so you can see the red lines are marking points where we have lowest growth. And so those are probably winters. The green lines are marking points of the fastest growth. So those are probably summers. And so what you've got, the last one is about halfway between a winter and it's not yet to a summer. And so from that, they conclude it's northern hemisphere spring is when this happened, most likely. because this is a deposit from the northern hemisphere, and these would have been fish living fairly close to that river, maybe even traveling up and down that river to mate. Yeah. So you can date it to within a couple of months in an unknown year. Yeah, but I think that's kind of neat. There's also some other lines of data, like you can look for pollen grains that are in the sort of impact material. They have also found a bunch of foraminifera that would normally be expected to be marine and on the bottom of the ocean floor, and those have been thrown all the way up inland, which tells you that something really bad happened. But the coolest thing that hasn't been properly published but has appeared in a TV documentary, because that's how some of these people roll, is this. It's the mummified leg of a dinosaur. And it's found in amongst these materials. And so it's likely that this dinosaur, so when it died, it wasn't scavenged. Nothing bad happened to it. It was just covered over by more, impact related debris. It's probably a dinosaur that died on the last day of the Mesozoic. That's a reasonable interpretation from this. That's only part of it, but the lower part. But yeah, fantastic preservation. So they're still presumably doing all the x-rays to work out like muscle structure, skin impressions. There's a lot of data to be mined from this thing, and nobody mines data better than vertebrate paleontologists. Wow, those guys are intense. So that's the bad thing. And you'd ask yourself, well, how did anything survive? But there were little animals, little mammals, little reptiles that would have lived underground. And stuff that lived in holes would have a reasonable chance of surviving as long as they could get back to their holes between the rains of molten glass. Because these are things that would last maybe, as long as a normal rainstorm, 15 minutes, half an hour of the glass hailstorm. And then things that could survive like that. Things that were near shore, pretty disrupted, generally dead. Things that were living in deeper water environments, some of those made it. Some of those are still around. Survived both the Paleozoic and the end Mesozoic extinctions. And so, spare a moment to think of our little relatives cowering in the holes. And this was the start. This was not just a bad event. It was the start of a very bad time. Because when you burn most of the forests and you destroy most of the oceans, you wreck the entire ecosystem. Because there's no more plants, or there are not many plants that are storing away that solar energy. And so the entire food web is just collapsing. And there would have been a lot of scavenging for a while. And then after that, times would have been really, really difficult. Behaviors like hibernation may have helped if there was enough food to sustain the animal so that it could actually fatten up a little bit to survive hibernation. A time that we'd like to know a lot more about, and a very interesting site, this Tanis site. And I would expect to see many more interesting papers coming out of this if people can stop fighting about it. It's an interesting place, and so it makes really big, important papers, and I see why people are fighting, but gosh, you wish they wouldn't. Yeah. So there you go. That's the day, literally day, the dinosaurs died. They were on the way out for a while, but this finished them off and most everything else. Yeah. So it's a sad way to end, but hey, everything's got to end, right?